So now we're going to do some optimization problems. Optimization is a fancy word for absolute max and absolute min. Our first problem here, we're going to do our same two steps. We're going to take the derivative, set equals 0, find the critical numbers, and compare those to the endpoints. Nothing to panic about. It's just a little bit of a different setup for these. So this first one, we want to find the number on the interval from 0 to 4. So there's my interval of interest, or the implied domain, called a couple different things. There's our interval, such that the number minus 3 times its cube is as large as possible and as small as possible. So the tricky part about this one is I'm not given my objective function. The function I'm trying to maximize or minimize isn't given to me, but I want to be able to take the derivative of it and set it equal to 0. So I really do need to figure out what that function is. I am, however, given my interval. I want to make this as big and as small as possible, but I can't just choose a billion to make it big and negative a billion to make it small. I have to pick between numbers 0 through 4. So the tricky part about this one is I need to figure out what the function is. So I need to read a little bit closer this time. So I'm going to find the number. I'm not told what the number is, so I'm just going to call it x, something we're used to having to find. So I want to find the number, which I'm going to call x, such that that number, I'll replace that number with an x, minus, well, what's the operation for minus? That's subtraction. That number minus 3 times its cube. So I need a 3 times that number's cube. What power is a cube? It's the third power. If it said number plus its square root, I would do x plus the square root of x. If it said that number plus 5 times its square, I'd do x plus 5x squared. But this one is the number, which is x, minus, which tells me to do subtraction, and then 3 times its cube means 3x cubed. So there's my objective function. I could call it anything I want to. I could call it O, but I'm just going to call it f of x and just be boring. Do what we're used to doing. We're going to do that number minus, I need a 3 in there, minus 3 times that number cubed. All right, once we have that, we're good to go with our two steps. We're going to find the critical numbers by taking the derivative and setting it equal to 0. So derivative of 1x is 1. Negative 3 times 3 is going to give us a 9x squared. And we're going to set that equal to 0. I have x squared. I could solve this by factoring. This is actually a difference of two square numbers. I could do 1 plus 3x and 1 minus 3x. But I think this one's actually a little bit easier to solve by the square root method. So I'm just going to try to get x by itself. So I'm going to subtract 1. That's my first thing I could do to get x closer to being by itself. I'd have negative 9x squared equals negative 1. And then I can divide by negative 9. And now I just have x squared. Well, negatives divided by negatives will just be positive. So x squared is 1/9. I'm a little bit closer. I just need to take the square root of both sides, and I need to remember, if I do the square root of a number, I need plus or minus, right? 5 squared is 25, but also negative 5 squared is 25. So now I can use a property of the square root. That says I can do the square root of the top and the square root of the bottom separately. So the square root of the top, the square root of 1 is 1, and the square root of 9 is 3. So I have two critical numbers. I have x equals a positive 1/3, and x equals a negative 1/3. So now I'm going to compare them on my interval of interest. Look at their y values. So I'm going to plug in f of 0, f of 4, and all of the critical numbers in between. So is 1/3 between 0 and 4? Yes. I'm going to have to test that. Is negative 1/3 between 0 and positive 4? No. It's not on the interval. That doesn't mean I erase it and it's no longer a critical number. It just means it's not on the interval of interest. We're not allowed to choose it. We have to choose between 0 and 4 and figure out the smallest and largest sums possible. So if you didn't know and maybe you guessed, you might say that plugging in 0 is going to give you the smallest sum and 4 is going to give you the largest sum. But let's see if that actually is true. So if we plug in 0, we're looking at y values, so we plug into the original function, 0 minus 3 times 0 cubed. That's just 0. If we plug in 1/3 to the original function, 1/3 minus 3 times 1/3 cubed, that gives us 0.2 repeating, which is 2/9. I'm going to write it as a decimal too so that I can compare it a little bit easier. So 2/9 or 0.2 repeating. And then if we plug in 4 minus 3 times 4 cubed, we get negative 188. So plugging the biggest number didn't give me the biggest answer. So not really the best option is to guess on these. So our absolute max would be 0.2. It's just a little bit higher than 0. So there's our absolute max that we could possibly get. And our absolute min is this negative 188. So then we want to see what's the answer to the question. We need to find the number in the interval. So I'm looking to find the number. I'm not looking for the biggest possible or the smallest possible. I'm looking for the actual number that yields these answers. So for the largest answer, the number we would plug in, or the location, is x equals 1/3. To get the smallest answer, it's not asking what the smallest answer is. It's not asking for the negative 188. It's saying what's the number that makes this happen. So we would type in x equals 4. Of course, if it asks the value, then we would type in negative 188 and 2/9. But this one is just asking the location.